Okay, so I'm going to kind of give a brief overview of the review for the test and kind of what to expect when you take the actual test. Now, like I told you guys in class, if you're able to do the review, you should have zero problems on the test. So I want to go through. I'm kind of going to brush over most of it because you guys told me, and basically what I saw is that you guys pretty much understood most of it. But I am going to touch on sets and subsets, and I'm going to touch on scientific notation for sure, because those two things you guys kind of struggle with. So I'm going to touch on those specifically and kind of brush over everything else. But for number one, it says which of the following statements is true. So basically, you have to do the computation for each answer choice to figure out whether or not what they're saying is true. Like the first one says the square root of 50 plus 1 is less than 7 and 700ths. So you need to kind of figure that out. But here's some advice I can give you. All right, I'm going to zoom in the calculator. If you put it in and you put um, the square root of 50 and then you just put plus 1, it doesn't give you the correct answer. It gives you uh, what the square root of 51 would be, because it's 50 plus 1 is 51. That's not what you're looking for. So the easiest thing to do would be to find the square root of 50, hit enter, and that gives you 7 and 7 tenths. And then you just hit plus 1, and that'll take the answer you got here and then add 1 to it. And so it's 8.07. That's what you're looking for. And so if you're looking for, if you look at 8.07, that's obviously more than 7 and 700. So you would, A is not the answer. So again, if you just do the number plus 1 in the calculator, it's going to put like 51 instead of 50 plus 1. Instead of, excuse me, it's going to put 51 instead of the square root of 50 plus 1. So what you want to do is you want to do the square root of 50, and then once you get that answer, you just hit plus 1, and that'll take your answer, and then it'll add 1 to it, and you'll get the correct answer there. So make sure you do that. Um, number two, Number two is asking which number is in between 8 and 2/3 and the square root of 80. So you just convert these two numbers to decimals and figure out which of these numbers is in between those two numbers. Which statement is false? So this is touching on the sets and subsets of rational numbers. And so I'm going to, on the back, I'm going to kind of give you guys another diagram. So the rational numbers starts with the natural numbers. Those are the counting numbers, 1, 2, 3, so on, all the way to positive infinity. Those are your natural numbers. The whole numbers, the whole numbers adds on. The whole numbers are all of these numbers, and it adds on the number 0. So 0 is the only number that's special in terms of the whole numbers and the natural numbers. So all natural numbers are whole numbers. Number 1, the number 1 is a natural number, is also a whole number. But not all whole numbers are natural numbers because 0 is not a natural number. So again, all your natural numbers are whole numbers, but not all whole numbers are natural numbers because 0 is not a natural number. The next one, and I'll use a different color. I should have changed colors before, but the next one is the integers subset. And so integers introduces the negatives like -3, -5, -100, I don't know. So it introduces the negatives. And so all whole numbers are integers, like 1, 2, 3, 0, those are all integers, as well as whole numbers. So all whole numbers are integers, but not all integers are whole numbers because negative numbers are not whole numbers. So we got to make sure we know that all whole numbers are integers, but not all integers are whole numbers. And then last but not least, we have the rational number subset, right? So this is rational. And so all these numbers, integers, whole, and natural, all those numbers are rational numbers. Those are subsets of the rational number system. So rational numbers include all these numbers plus percents, decimals, percents, and fractions. Okay, So rational numbers include integers, whole, and natural numbers, as well as percents, decimals, and fractions, right? And so we also learned that there are irrational numbers, and irrational numbers are usually irrational numbers are usually away from the rational numbers. So the way I like to think of it is like an irrational person. If a person's being irrational, that means they're being kind of crazy. And if you're rational, that means you're not being crazy, right? So if you're rational, if you're a rational person, you don't want to be around someone who's irrational, right? So that's kind of what we look at it. These rational numbers are separate from these irrational numbers. And that's kind of how you can remember it. Irrational numbers are separate from the rational numbers. They're both real, but they're separated because these are rational and these are irrational. And irrational numbers like pi, or an imperfect square like 26, or imperfect square like 31, or any imperfect square, those are irrational numbers. And so those are numbers that don't terminate and they do not repeat. So they don't terminate and they don't repeat. Those are irrational numbers. And so we have the rational number subset, and then we have the irrational number subset. These are all subsets of real numbers. So if they ask you, hey, is a rational number a real number? Yes. Is an irrational number a real number? Yes. Is an integer, is a whole, is a natural number, are those real numbers? Yes. Those are all real numbers. A real number is any number I can put on a number line. And I can put any of these numbers on a number line. I can also put those on a number line. Those are all real numbers. So going back to the question, it says which statement is false? The set of rational numbers is a subset of real numbers. Well, that's true. We just discussed that. Rational numbers are real numbers. That's true. The set of irrational numbers is a subset of real numbers. We just discussed that. Irrational and rational numbers are both real numbers. So that's true. It says the set of integers is a subset of rational numbers. And if you go back to the chart, it is. Integers is a subset of rational numbers. Therefore, that is true as well. The last one says the set of irrational numbers is a subset of rational numbers. Not true, because again, rational and irrational, they are separate. They don't like each other. So D is the correct answer there. All right, looking at number 4. It says which line shows the best approximation of the square root of 220. So in your calculator, you're just going to put okay. So in your calculator, you're going to put the square root of 220, and you get 14.83. So on my number line, I'm going to kind of look at which one is closest to 14.8. This is between 17 and 18, not my answer. This is between 19 and 20, not my answer. This is between 15 and 16, not my answer. This is between 14 and 15, kind of close to 15, which would make sense since it's 14.8, so that's my answer. Okay. Number 5 says which of the following values makes the inequality statement true. So basically, we're trying to figure out which number is in between this number and that number. And so in our calculator, if you're given a fraction inside of a square root, here's how you do that. So you want to open up the square root, right, which is control and then the x squared button. So you want to, let me zoom in. I'm going to open up the square root. Then you want to hit Control Divide, and that gives you the option to put a fraction inside of a square root. And so here we would just do 18 and then 29. I'm sorry, 29, and that would get us the decimal for. I'm sorry, I didn't realize you could see it. So you have 18 over 29. We hit Enter, and that gave us the decimal for that number, right? And so we would come back here, and you would write that number here, and you would kind of figure out what that one is, and then you figure out which number is in between those two numbers. So that's how you do that. And So this one is again about sets and subsets. So we have number 6 says which Venn diagram correctly shows the relationships between the subsets of real numbers. So all these numbers are real numbers as we discussed. If you do not see rational and irrational separate, then that answer is automatically wrong. Like D is wrong already because rational and irrational in the same box, and that can't be the case. And so it's either A, C, or B, right? And so B is wrong because it has irrational here, and it has natural, whole, and integers as subsets of irrational numbers. They're subsets of they're subsets of rational numbers. Therefore, B can't be the correct answer. C, let's look at this one. A has natural numbers, a subset of integers, which it is, but it says integers is a subset of whole numbers, and that's not the case. Whole numbers is a subset of integers, so A can't be the correct answer. Looking at C, we have natural as a subset of whole, which is a subset of integers, which is a subset of rational numbers, which are separate from irrational numbers, all under the real number system. So C is the correct answer. All right, so look at number 7. It says which of the following number lines correctly places the following irrational numbers. So these questions, you simply figure out the square root and then use those numbers to tell you where to place these numbers on the number line. And so your calculator will help you with that. Again, I'm not going to go specifically because you guys know how to do these. All right, number 8. The sun is approximately 4 billion years old. Yeah, 4,603,000,000 years old. How is this number written in scientific notation? Okay, so this one is a good one because it's important for you to know that you have to include this 3. Even though there's a 0 here, you have to include this 3 as your coefficient. So we're going to take this number, the decimals here at the end. I'm going to move 1, 2, 3, 4, 5, 6, 7, 8, and 9 until I get to 4.6. So 4.6. Now you just can't write the 4.6 because there's an integer here. We got to go all the way to this integer. So 4.603. Then we can say times 10 to the 9th power. So these answers are here waiting on you, right? If you just go to 4.6, you think this is the answer. It's not. Okay, that's not the answer. This one is wrong on the exponent and is wrong as the coefficient, so that's not the answer. This one says 4.63. It takes out this 0, and you can't do that because that 0 is in between two integers. That's not the right answer, so it has to be this one. 4.603. Then you go 10 to the power of 9. Okay, so number 9 talks about the real numbers in ascending order. Remember, ascending means you go from the bottom up, so least to greatest. So ascending is least to greatest, and then descending will be greatest to least. So remember to put these numbers in decimal form, and if you need help with this fraction here, we would just use the control division button to give us, again, we hit control division, and that gives us the fraction, the empty fraction. So we take the square root of 180, and we put that over 3, just like that, and then you would enter, and that would give you your decimal. So make sure control division will give you that empty fraction. And so you would convert these numbers to decimals and then put them in order from least to greatest, because ascending means least to greatest, descending means greatest to least. Okay, so we have another scientific notation question. It says the smallest length of a bacterial cell is 7.9 times 10 to the negative 6. How's it written in standard notation? Okay, so we take this number, 7.9, and maybe I should write it over here. more space, 7.9. And so it's to the -6. If it's a negative, remember we're going left. That decimal is going left. And then this tells us it's going left 6 spaces. So we go left 1, 2, 3, 4, 5, 6. And we fill in zeros. And so D is automatically not the correct answer because we saw the decimal. So really you just need to count the zeros 1, 2, 3, 4, 5. And then so 1, 2, 3, 4. 1, 2, 3, 4, 5. So this is our answer here. We have 5 zeros and then 7. So again, you just take that number, the coefficient, and then you move it to the left 6 times because it's a -6. And so you move it to the left that way. Alright, so the next question gives you another situation where it wants you to put them in order from greatest to least, so descending order. So again, you need to put these in decimal form, and then so you can order them, and then once you order them, you have your answer here. Same thing on the next question, just an ordering question. Put them in decimal form, and then order them. Alright, so one last thing I want you guys to have on your review. Again, if we're talking about the square, let's say they give us a problem and it says, hey, the wall is a square wall. And I know that's not a perfect square, but you get the picture. The wall is a square wall and it has a area of, let's say, 100 square feet. Well, to get one side of this square wall, because a square is a base times height, that means it's going to be this number times this number. I need to think, well, which two numbers multiply by each other? It's a square, so the number has to be the same. Which two numbers? Which number can I multiply by itself to give me 100? It would have to be 10. 10 times 10 would give me 100 square feet. And so whenever they ask you for the side length of it, let me do it differently. Whenever they ask you for the side length of a square, they're really asking you to find the square roots. So whenever you see it says, hey, something is a square, well, usually that means we need to find the square root. So make sure you know that. Other than that, if you have any specific questions, send me an email and I will get back to you as soon as I possibly can. I have practice until 7, but after that, I should be able to get in contact with anybody or your parents. They can contact me on Remind, and I can try to answer any questions you may have before this test tomorrow.